Welcome back. Today's video is going to be about something a little different than we've learned before. But we're going to start with solutions again. So we learned last week and a little bit this week that solutions are created when things are dissolved in water. So you can get some really cool stuff to happen that would never happen otherwise if you dissolve substances like salt or other things into water and create a solution. But something weird happens when you bring in a substance like this. So this is oil. It's vegetable oil, I believe. And you've probably seen this happen before, but if you try to mix vegetable oil with water, it won't mix. It sits right on the top and refuses to mix with the water. Now you can try and stir this if you have some at home, but no matter how you stir it or blend it, it will always separate just like this. Now, why does that happen? This is like an anti-solution substance. It's very strange. The reason for this is oil is based on the element carbon. And carbon is one of the most unique, probably the most unique element on the periodic table. This substance is so cool, and it reminds me a lot of, it makes me think about like God's favor and God's creativity when making the world. Carbon is called the element of life, and there's a reason for that. But let's talk about it chemically first. Carbon is element number 6 on the periodic table, which means that it has 4 electrons in its outer shell. And if you look in group 14, as you go across, remember you subtract 10, and it's 4 electrons in its outer shell. And interestingly, it is the only non-metal that has 4 electrons in its outer shell. Right below carbon is the first metalloid in that group. So metalloids act differently than metals and nonmetals. So the only nonmetal that has 4 electrons in its outer shell is carbon. So we learned that if a substance has 5 electrons in its outer shell, it wants to try and add 3 more electrons to make a full set of 8. Or if it has only 3, it wants to try and lose those so it can go down to the shell below it. But what about 4? 4 is balanced perfectly in the middle, and it could go either way. So what does carbon actually do? And this is why it's so cool and makes me think about God, is it's like the difference between destruction and creation. Carbon does not decide to destroy its electrons, to get rid of them, to pass them away. It decides to add 4 more. Because it decides to build bonds rather than get rid of them, it makes the whole world able to be so much more rich and complex. Because carbon's ability to form 4 bonds is unique. No other element forms 4 bonds with molecules around it, and it forms covalent bonds most readily, most easily. So the reason it's called the element of life is that every organic living thing has carbon in it. I'm talking everything. Like every molecule in your body nearly has carbon in it. Your skin, carbon in it. Your teeth, carbon in them. This oil has carbon in it. It's based on carbon. The wood in this table is based on carbon. Every single living organic thing, everything based on life, anything that comes from life, has carbon in it. So the element that could have gone either way, but decided to build instead of destroy, is the one that life is based off of. The thing that is most special about our world. I just think that's amazing. So what does this mean for chemistry? Well, in a mixture like this is actually the difference between, you can see it visually, the difference between a polar substance and a non-polar substance. A polar substance, like water, has, if you look at its molecule, has a difference in charges depending on where you are on the molecule. So one part of the molecule is like more positive, one's more negative on the other side. There are lots of molecules like this. But the point is, polar substances are the only things that can dissolve polar substances. So salt can dissolve in water because salt is also polar. However, oil and other carbon-based things are usually, almost always, not quite always, but they're usually non-polar. That means if you have a molecule that's carbon-based, there's no part on it that has a different charge than the other. Everything is equal. Everything's all spread out evenly. So a polar substance cannot dissolve a non-polar substance at all. They simply don't mix. Nothing happens between them. And this is what creates this funky looking thing right here. So these things that are carbon based, there's a whole brand of them called hydrocarbons. Hydrocarbons are molecules and substances that only have hydrogen from hydro and carbon in them. Hydrogen and carbon. Hydrogen has, if you remember, has only one valence electron in its outer shell. So because it wants to make one bond and carbon wants to make 4 bonds, the most basic hydrocarbon that you could have is one carbon surrounded by 1, 2, 3, 4 hydrogens. There is an entire world of hydrocarbons. In fact, there's like entire college courses just on hydrocarbons, and they are so in-depth and so detailed. But we are just gonna scratch the surface of this. But our chapter so far has been about solutions, and these substances make up a group that form solutions of their own. There are substances that will only dissolve in a non-polar substance like this oil and will not dissolve in water. So there are lots of, in your body even, there are solutions that are non-polar, and they can do all kinds of other things beyond what regular solutions can. So that's all for today. Thank you very much.